My name is Marissa Brown, and this is Artifact 11, Standard 6.2, ISTE Criterion 20, Manage the Use of Technology for Learning in a Non-Traditional Class Setting. In Artifact 11, I created a creative computing project that I implemented with my 8th grade physical science gifted students. For this project, I taught students how to code using Microsoft MakeCode and Microbit Inventor Kit by creating circuits. Students did this by using the MakeCode website to learn block-based coding while utilizing SparkFun's Inventor Kit to teach students how to breadboard, such as making their first LED blink and or control the servo motor. Students created a robotic pet. This project focused on Georgia standards of excellence, obtain, evaluate, and communicate information about the properties and relationships between electricity and magnetism. Element B, develop and use models to illustrate and explain the conventional flow of current and the flow of electrons in a simple series and parallel circuit. My rules and procedures were guided by Gwinnett County Public Schools' responsible use of technology and electronic media for students. In addition, in the beginning of the project, these rules were posted on the board. We reviewed them as a class and explained what each one meant. These rules were posted on the board for students to see during the duration of the project. Besides reviewing rules that I had posted, some additional ways I managed the class was modeling specific tutorials on Microsoft MakeCode and Spark Fun tutorials for Breadboard, but also allowing students to pick several on their own after modeling. We used the Ask Three, Then Me approach, where students were required to ask 3 other classmates before me. This way, their peers could show them how to complete circuits, and it really boosted some students' confidence. I would consistently monitor students by walking around and checking in with them, and they were able to work in collaborative groups of their choice. Artifact 11 proves as evidence that I manage the use of technology and student learning strategies in digital platforms, virtual environments, hands-on makerspace, or in the field. My name is Marissa Brown, and this is Artifact 11, Standard 6.3, ISTE Criterion 21. Create opportunities for students to use a design and or computational thinking. In Artifact 11, I created a creative computing project that I implemented with my 8th grade physical science gifted students. For this project, I taught students how to code using Microsoft MakeCode and Microbit's Inventor Kit by creating circuits. Students did this by using the MakeCode website to learn block-based coding while utilizing SparkFun Inventor Kit to teach students how to create and utilize the breadboard. Students created a robotic pet. Students utilized computational thinking using Microsoft MakeCode and Microbit Inventor Kit. The 4 elements were decomposition, pattern recognition, algorithm, and abstraction. Students were assigned a creative play journal that they could personalize to showcase a little about themselves. In the Microbit Design Journal, students were introduced to the creative play cycle, which consisted of 5 stages: inspire, imagine, build, play, and share. They were inspired by a young boy who used the microbits to create a robotic friend, and they wrote down all the things that they were inspired about watching the video. They then imagined what their robotic pet would look like. They then built their robotic pet, they played with their robotic pet, and they shared their robotic pet and what it was capable of doing. They also shared their code so that other students could attempt to recreate some of the functions that their robotic pet was able to do. Artifact 11 proves as evidence that I created learning opportunities that challenge students to use a design process and computational thinking to innovate and solve problems. My name is Marissa Brown, and this is Standard 6.4 ISTE Criterion 22 for Artifact 11, Model and Nurture Creativity. In Artifact 11, I created a creative computing project that I implemented with my 8th grade physical science students. For this project, I taught students how to code using Microsoft MakeCode and Microbit Inventor Kit by creating circuits. Students did this by using MakeCode website to learn block-based coding while utilizing SparkFun Inventor Kit to teach students how to utilize the breadboard. Students created a robotic pet. I modeled creativity with my students by showing them my version of the design journal that I created in my iTech 7485 class, as well as the codes I use on Lola the robotic zebra. In addition, we did series of tutorials together like the flashing lights and the servo motor in order to help inspire them in their imagination and build phase on what functions they might want their robot to do. I also showed them some of the videos that I had to create in the class as well, and they were really inspired and they couldn't believe that their teacher had the brain power to do that. When introducing the microbit, we used Microsoft MakeCode. I had every student attempt the flashing heart tutorial with me, then gave students the opportunity to select another whole class tutorial before allowing them to do 1 to 2 additional tutorials with their partner on their own as I monitored the classroom. Additionally, I had to introduce students to the breadboard in the SparkFun Inventor Kit. Students had to utilize both the microbit and the breadboard, creating a circuit to power their robotic pet. As a class, we did 2 experiments together. Then students in their groups could choose to do a few more on their own. These tutorials helped them determine what functions they wanted their pet robot to perform. The sky was the limit for students. I wanted to provide students with the opportunity to create whatever pet robot their hearts desired. Students made penguins, birthday cakes, octopuses, and more. Students worked with their peers in creating their project, but also were able to receive technical support from peers on functions they were struggling with. In Essential, this created expert groups or expert students. Here are 2 examples of the videos that students created of their robot where they shared some of their successes and some of the areas for improvement. Where would they go back to fix and why would they fix it? One group created a cow where where they wanted the eyes to blink, but they were unsuccessful doing so, but they were able to have the mouth move. Another group created an octopus with movable tentacles and blinking eyes. Students also had to make the connections to their circuits in their video and explain their process. These recorded videos were put on Flip for other students to see and give feedback on, as well as for other teachers and administrators to view. Artifact 11 proves as evidence that I modeled and nurtured creativity and creative expression to communicate ideas, knowledge, and connections.